Good morning to all of you. I welcome you to this session on RDBMS. In today's session, we are going to discuss about joins in SQL. We'll be also discussing the entity relationship model or the ER model, and we'll be starting the relational model as well. So what exactly is a join? Right now you see the syntax of join in front of you. A join is when you require to fetch or extract information from multiple tables. Currently, like you've learned the select statement, and we have been working on extracting information from a single table. Sometimes you need to extract information from multiple tables. In that case, you require something which is known as a join. Okay, so you can join the tables using this SQL 99 syntax. There is an older syntax also, okay, which is known as the Oracle proprietary joins. Okay, we'll discuss that syntax also, and this new syntax also. This new syntax came into force from Oracle 9i onwards, right? So just have a look at this syntax. It is select, then the columns that you need to fetch, then the name of the tables that you're going to join. And there are various options through which you can join tables. You can join it using the natural join clause. You can join it using the join using clause. You can join it using the join on clause. Okay. Then you have the outer joins, the left, the right, and the full outer join. Then you have the cross join. So we'll be discussing all these things in today's session. So for that, let me just start a SQL session for you. I'll connect it as the user spot. And then we can just make some initial settings so that the outputs are clear to us. All right. Then as usual, we'll be focusing. Currently, we are focusing on these two tables to practice things, right? So if you have a look at these two tables, the emp table and the department table, you see there is a common column, that is department number. Okay. There is a common column, department number. So you can join these tables on the basis of this common column. Okay. So first I will write the older syntax to join tables. Okay. So kindly note, select column list from table 1, table 2. So you can have multiple tables where we have a join condition and additional conditions. This is a syntax for joining tables. So you have first the column list. Column list would mean which columns you want to display. Then the name of the tables that you want to join separated by commas. Then you have something known as a join condition. Okay. So join condition, like if you have two tables, then you must have a minimum one join condition, at least one join condition. And if you have got three tables, then minimum two join conditions. So if we have n tables, then we must have n minus one join conditions. And if you don't write it according to this plan, your query won't run, right? And then you can have any number of additional conditions in your query, right? Okay, kindly note this thing. So I'm writing a join for this. For example, I want to display the employee number, the employee name, salary, and the name of the department to which the employee belongs. So in this M table, there is no name of the department. There's only the department number to which the employee belongs. The name is here in this department table. So we need to join these two tables to get the desired information, right? So I'll write this query here, select emp number, comma ename, comma salary, comma department number, comma dname. Okay. So this column here, department number, is there in both the tables. It's here also and it's here also. So writing it just like that can be ambiguous to the Oracle engine. Okay. So it will give you an error initially. I'll show you that error first. Then you write the name of the tables here. Okay. And then you write the join condition. This is the join condition. So the join condition is based on the equality of values of this column here and this column here. Okay. So we must write here m dot department number is equal to department dot department number. This is our join condition, right? So two tables we are going to join. So we have one join condition. Just see how this join condition is written. This join condition is on the equality of the values of a common column in both the tables, right? Okay, fine. I've told you this will give you an error because this field here, department number, this column is ambiguous. The Oracle engine does not understand whether to take it from this table or to take it from this table, right? So this will give you column ambiguously defined, right? So how you can correct it? You can just prefix the table name, any table name you can prefix. M for department, the choice is yours, right? So if we write here, then we get a join. You see, we are getting the columns from the one table and then this column from the department table. So now we can see that Smith belongs to research department. And if you look here, if you look only at the M table, right? If you look only at the M table, you don't have this information here. Here the information is Smith belongs to department number 20. This is a more meaningful information that Smith belongs to department number 20 and the name of the department is research, right? So this is possible with the help of this query. You can see, you can have a look at it. In this query, these are the tables which are being joined. Two tables are being joined. So we have one join condition. If three tables would have been there, then minimum two join conditions, right? Okay. And we can also modify it, like usually the business tables that we have for the organizations, they've got big names. So writing them again and again can be time consuming. So what we can do is we can give some aliases to our table names. For example, in this way, I'm referring that in the query, M would be referred to by E and department would be referred to by T. So you can just make this change everywhere. You can just write here like this. Okay. Similarly, so it will just reduce your work. So these are known as this E and D. These are known as table aliases or nicknames for tables. Right. If you run this query, this will give you the same answer. Okay. So this is the old syntax. Okay. This is the syntax which we worked with when we had Oracle proprietary joins. Right. Then come SQL 99 syntax, okay, and we have a different way of expressing the joins, right? We'll discuss that. This type of a join, okay, where the values which you return are based on the equality of the column in two tables is known as an equijoin or an inner join, okay, an equijoin or an inner join. Remember the nomenclature, an equijoin or an inner join, right? Then let's see the syntax which I just displayed. Let's use this syntax, the latest syntax now, which is easier to write and easier to express. And then I'll discuss the old syntax for the outer joins, right? Okay, and the new syntax also. This is a new syntax. I'll discuss the old syntax also and the limitations of the old syntax here, right? So I'm writing this now, select, I can pick up some column names. Okay, I can pick up the same query here. So here I can use a word natural join. Okay, so when you write simply M natural join, then the department, that means you are taking a natural join of these two tables, M and department. By natural join, we mean that it would result into a join where it would match, it would result the rows which would be from all the columns with similar names in both the tables. Okay, you are not mentioning any column, you are not specifying what this join should be based on, because natural join means that if two columns have similar names in both the tables, a join would be based on that. Okay, so this is the natural join. You can see the output here. So natural join can be confusing sometimes because there may be, in bigger tables, there may be many columns with similar names in both the tables. So ideally we pick up a column on which we want our join to be based. Okay, in that case you can remove this word natural from here and you can pick up the using clause in which you specify the column on which the join should be based. So just have a look here. I'm using this join using. Okay, join using. Okay. So how it is done? Have a look. From, then you write here M, then the keyword join, then the other table name, and then the using clause in which you mention that on what column these two tables should be joined. So you are specifying that these two tables should be joined on the basis of department number. Okay, so you can see the output again. The output is same, and you see there are 14 rows which are matching. I hope this concept is clear to you. So just list out the things for you so that we can discuss. Say select star from, I've listed both the tables. Now when I make a join like this, okay, so I'm looking for the department number values which are common in both the tables. So if you look at this first row, there is a department number 20 here. Okay, so it matches with this 20. So one row results. Then the second row department number is 30. The 30 is here. So there are 14 rows in M table in which the department number matches with the department number in department table. So we get the 14 matching rows like this. Okay, this is how the the equi-join or the inner join works. Okay, I hope I have made my point clear. So this is the second way. The first way was to use the word natural join, where you don't specify any column name, right? This is a syntax in front of you. You don't specify any column name here, and the join is based on equality of columns having similar names in both the tables. Like in our example, there is only one column, department number, which is having which is occurring in both M and department. So we get the join like we have shown above, right? And a better way would be to write like this, in which we specify the column on which we want to base our join, right? So that is done with the using clause like this. You can see the syntax and see now there is no confusion here. I've written department number as it is without any table prefix. So when we use the using clause, there is no problem with this. Okay, now let's have a look. Let me just change it. Let me write here the on clause. Okay, if I write here on, then I need to mention a condition here. Okay, then I need to mention a condition here. M dot department number is equal to department dot department number. So remember this thing, that when you use on, you write a condition here. When you use using, you write the column name here. Okay, and when you write like this, this would be ambiguous again. Okay, I'll just run it first to show you the ambiguity. Okay, that means when you are using the on clause, then you must prefix it by which table you want the value from, because the value would be same, but you must mention the table name here. Okay, if you run it, it's fine. And then you can shorten it also. As I told you, you can give table aliases like this. Okay, and like this. So here in this query, I'm referring M through E and department through D. So again, this would be now giving you the desired results. So remember, we have discussed three clauses here: the natural join, then join using, and then join on, to mention to or refer to our equi-joins or inner joins. Next, I'll discuss the outer joins with you, right? Next, I'll discuss the outer join. So let's suppose I'll first list the tables for you: the M table and the department table, right? Now, I want to display the values which are matching. When I join these two tables, I want to display the matching values as well as the non-matching values. So what is the non-matching value in both these tables based on department number? That this department number 40 is not having any occurrence here. Okay. So when I make an equi-join or an inner join, then I get 14 rows which are matching. So sometimes I would require the non-matching rows also. Okay. Then we refer to that join as an outer join. Okay. I'll write an example first for you for the outer join. So I can just pick up some columns here: emp number, e name, salary, then department number, then d name. The similar query I'm writing here from emp comma department, and then see how the join condition would change, where emp dot department number is equal to department dot department number, right? This is the outer join condition. So you put a plus sign, either you put it here or you put it after department number. Okay. So wherever you put the plus sign, that means that that relation or that table is the deficient one. That means we want the non-matching rows from the other table. So when I write this query, listen carefully, it would display the matching rows from both the tables, that is the 14 in number, right? And the non-matching row which exists in department table and not in M table. You can see that non-matching row is 40. Okay. So here it will come, and also I need to qualify it. I'll just write department number here, write department here. Okay. So you'll see 15 rows now. Okay. So see the 14 matching rows. Let's be very clear about this outer join. These are the 14 matching rows, and the outer join would mean that the non-matching row would also come, and you specified, when you put a plus sign here, you specified that the non-matching row should come from the other side of equal to, that is from the department table, and that row is this 40 and operation. So you can see the value 40 and operation here, and from the emp side you can see the null values, nothing is there. Okay. Since the values are coming from department table, which is mentioned on the right, so this is known as the right outer join. Okay, this is known as a right outer join. Kindly note this thing. Okay. To understand the left outer join, I'll just add a value into my M table. So I can just write like this. I won't mention a department. Okay, I'll mention these three things. And I can mention like this. Then I can give this value here and say I can give this salary here. So this row is now created. So if I again list the tables, see the scenario now. Now I have 15 rows in my M table, kindly note, okay, and 4 rows as usual in my department table, right? And now when I do an outer join, I can either pick up the non-matching rows from M table, that would be this value, or from the department table, that would be this value. So I'll run the previous query again. This we used first, right? This is our right outer join. I'm sorry, yeah. Let's just come to that point. Yeah, this is our right outer join. Okay, because this table department is mentioned on the right, the emp is mentioned on the left. So you're suggesting with this plus sign here that the non-matching values should come from the table which is on the other side of equal to, that is this department table, right? Okay, so see, this is my right outer join. Now I'm going to write a left outer join. Let's put this plus here. Okay, now what I mean here, that matching rows from both the tables, and this plus is here, so values should come from the other side. So values would come from the M table. So we'll have 14 matching rows, and we'll have one non-matching row as 1000 Ajay, and this salary, we are displaying salary, so salary would also come here. Okay, look at it now, look at the output. It's the other way around now. Okay. And sometimes we would be interested in, picking up values, non-matching values from left as well as right. In that case, we term it as a full outer join. So I've not been able to find a syntax for that. That means if I try to do something like this, it is not possible with this syntax. Okay, so this will tell you that you just need to refer only to one outer join, right? So we are not able to see a full outer join here using this plus symbol. This can be put only one on one side of the equal to. Okay, I hope you understood this outer join. Now I will do this outer join with this syntax. Okay, with the latest SQL 99 syntax, right? The left, right, and full outer join, which is easier to write without any confusion of where to put the plus sign, right? So have a look now here. I'm going to write this. So just see the words here. We'll just change the words. And when you put these joins, you will just mention those on and using clause as usual, right? So from emp, just write here left outer join department, and then where you can put a using clause here, using department number. So you remember that when you use this using clause, you don't need to prefix this by the table name. So this is a left outer join now. Something that you have written here. Okay, this is a left outer join. Okay, now this can be written using the latest syntax like this, simply by putting a word here, left outer join. So emp left outer join department. This will fetch you 15 rows, 14 from the matching and one non-matching from the emp side. Like you have this displayed here, the same output would be there now. So you can just have a look here. This is the left outer join, right? Similarly, you can have the right outer join. Okay. In the same way, you can have the right outer join. You can see that now the non-matching values comes from the department table. And to finish this discussion, you can also have a full outer join. Now you'll have 17 rows. Oh, sorry, 16 rows, 14 matching, one non-matching from the emp table, that is this value, and one non-matching from the department table, that is this value. So have a look at the output. Okay, 14 matching rows. I've highlighted that. You can see these are the matching rows. Then this is the non-matching from left. This is the non-matching from right. So this is a full outer join. You can see that. And I have used the using clause here. You can use the on clause also. Okay, I'll just modify it here one by one. I'll just write here on, and I can write E dot department number is equal to D dot department number, right? And then I can put some aliases here, M, and I can put an alias here, D, and I'm using on, so I have to write it either E dot or D dot. This is your full outer join, right? Similarly, I'll go with a left outer join, so that you see that it works with every syntax. This is a left outer join, right? Then I can put a right here and see this is the right outer join. So it can be done by both the on and the using clause, and with the keywords right outer join, left outer join, and full outer join, right? One thing is now left in this full syntax is this cross join. Okay, so the old syntax here for cross join would be simply select, say, emp number, comma, e name, comma, salary, comma, d name, say from emp, comma, department. So you don't mention any join condition here. Okay, so this is a cross product or a cross join. Okay, so this would result in a combination of each row from the first table with the each row of second table. So in our example, we have 15 rows in the M table. You can see that. I'll just display. Okay, you know that there are 15 rows in M table and 4 in department. So this query would be resulting in 60 rows, right? Every row of first table, M table, matches with every row of the second table. So you can see how this has come. 15 into 4, 60. And SQL 99 syntax for this would be simply cross join department. This would be having the similar output. You can see these two syntax. The older syntax, we just mention the tables without any join condition, and then with the word cross join here to mention to this cross product or cross join, right? So this is all regarding joins. You see, you need to practice it. It is very helpful at all your workplaces, in your projects, in your applications, you'll be requiring this combination, when you are extracting information from multiple tables. So it would be required most of the time. So all the more important for you to practice it. So let's now discuss the entity relationship model. Okay, we'll first discuss what is an ER model. Okay, and then if time permits, in today's lecture we'll be discussing the relational model, right? So this entity relationship model, or the ER model, it is a high level conceptual model. Okay, conceptual models are used to design our databases, right? So this model was given by P.P. Chen in 1976 to facilitate database design, so that we could design our databases, our tables, in a better way. Okay, and we see that conceptual modeling is a very important phase, and it's a very important fact in designing a successful database for an enterprise. Remember this thing, right? Conceptual modeling means we first see how we can relate the entities and the relationships between them, among them, and then we can design our tables or database. Okay, so for that, I'll just take you to some. Yeah, I hope you can see my screen now. Okay, so this model is a high-level conceptual data model given by P.P. Chen in 1976 to facilitate database design. Right. Okay, two things are there in this. Remember, the entity and the relationship. So the first question that would come to mind is, what is an entity, right? So entity, you see anything which is of interest to an organization. One definition. Or entity is something for which an organization is going to maintain data. Fine. So, for example, if we take the case of a college, then student is an entity. If we are in a room, then fan is an entity. Okay, chairs is an entity, table is an entity. So anything which is of interest, for which we are maintaining data, okay, that is an entity. And an entity has got some attributes or characteristics. For example, a student has got the characteristics such as his roll number, name, sex, date of birth, class, marks, sports which he plays, like so much information is there. Okay, so all the characteristics which an entity possesses is the attributes for that entity, right? Okay, so let's go and discuss this. The ER model terminology. Entity is objects about which information can be stored. For example, specific room, specific part, specific student, etc. Attribute is the property or characteristics of entities. And then comes the relationships. Like if we are trying to relate to entities, then what sort of an association exists between them is termed as the relationship. Okay. And then next we have the degree of relationship. Okay. Degree of relationship is the number of entities associated with a relationship. Next we have the cardinality of a relationship. That means how many occurrences of one entity are related to one occurrence of another entity. Okay. Then we have the connectivity of relationships. Okay. Connectivity is a very interesting aspect. Connectivity is like how we can relate entities. For example, the connectivity could be 1:1. Okay. 1:1. Or it could be 1:n, which is also known as 1:many. Or it could be many:1. Or it could be many:many. Okay, I'm repeating. This is 1:1. That is a 1:1 association exists among entities. For example, one department and HOD. One entity is department, one is HOD. So usually there is a 1:1 association between department and head. Okay, then 1:many. Okay, so if you look at an example of books and authors, I'm giving you a very good example, books and authors. So one author can write many books. So this is a 1:many relationship, right? One author can write many books, that is 1:many. Many authors can combine together to write one book, that is many is to one. Okay. So if we just sum it up, the relationship between books and authors is termed as many is to many. Simply because both the aspects are there. One is to many is there, many is to one is there. Right? So this way we design our entity relationship diagrams or entity relationship models. Okay. So then we have the things here. You can just have a look at these definitions: entity, entity set. Okay. Then attributes are there. Okay. Attributes of an entity, like attributes of a student, attributes of a fan, attributes of a car, attributes of a table, and so on. For example, if we consider the student entity, you can see it can be described by its roll number, the name, class, etc. Okay. So next we have the types of attributes. Important thing you can just see. So the attributes of an entity could be simple, could be composite, could be single valued, could be multi-valued, could be a derived. Okay. A simple attribute is which cannot be split or which is not divisible. Okay. For example, we have the price, okay, the registration number, the Aadhaar number. Okay. These are simple attributes. Then we have composite attributes. Composite attributes are which can be broken further, right? So for example, a name attribute is a composite attribute because then we can break it up into first name, middle name, and last name. Then we have single valued attribute. That is a attribute which can only pick up a single value. Okay. Right. Age is a single valued attribute. So we can also have multi-valued attributes. Okay. So a multi-valued attributes is an attribute that holds multiple values for a particular single entity. For example, color of a car. This attribute can have different colors, different values. So it is a multi-valued attribute. Then we have the derived attribute. Okay. Then we have the derived attribute. So a derived attribute is an attribute which can be derived from an existing attribute. Okay. For example, if we have a date of birth attribute. Okay. Interesting thing. If we have a date of birth of a student or an employee, we can derive the age from it. Okay. Simply what we can do it from the current date, we can subtract this date of birth to get the age of the employee or the age of the student and so on. Right. So this is derived attribute. Then a null value, as we discussed, a null value is, it can have two sort of scenarios. Something which is missing or not known. Okay. For example, missing or not known would be a PAN number, like somebody has applied for a PAN number, then that is not available, is just waiting for it to come. So right now its value is missing or it's unknown or not known, right? And sometimes the null value would be not applicable. For example, if you see when we are filling up the address for some student or an employee, there could be fields like address, then street number, lane number. So some student or some employee would be having a residence where there is no lane number. So for that, it would be not applicable. Okay, so remember, a null value is neither a zero, neither a space. It is simply a value which is currently missing or not known, or which is not applicable. Remember this thing. Okay, and special treatment is required for null values, right? Then we discussed about the relationships. So we can have a unary relationship. Okay, so unary means single, then a binary relationship, ternary relationship, and quaternary relationship, right? Okay. Then connectivity we have already discussed. There are a few examples here. Okay. So a 1:1 relationship could be between a project carried out by a student, one project sort of thing. So you can just have a look at it. I'll share this file with you. Okay. The idea here would be to, to focus on the relational model, how we can use all these things in our relational model, and how we can design some good ER diagrams with the help of all the information that we have about an entity and its attributes. Okay. So now how do we draw this diagram? Okay. Right. So we have an entity. Okay. Entity we represent using a rectangle and enclosing its name within it. Okay, so you just see these things. It's very easy to design. It's a graphical representation of the entity and its attributes. Okay, then The relationship between entities would be represented by diamonds. Okay. And the name of the relationship is enclosed in diamond. Then link line attributes are there. Ellipses are there to represent attributes. Double ellipses represent multi-valued attributes. Dotted ellipses denote derived attribute and so on. Okay, so all that help is there. All those diagrams, figures are there. You just need to connect them to make a good ER diagram. You can now see it here. Okay, these are the various ER diagram symbols. So entity enclosed in a rectangle and name of the entity written within it. Attribute in an oval, okay, a multi-valued attribute in a double-lined oval, a derived attribute in a dotted oval, a composite attribute as you see it on screen like this, okay, right? And the relationship when you connect to entities, for example, student and teacher, we can draw a ER diagram for that, okay? So we can have a relationship that teacher teaches a student. So relationship would be teaches or mentors or guides like this. Okay. So when we practice about these diagrams, the thing should be clear, but see how we can put the things together. Okay. A primary key is referred to by putting an underline below the attribute name. For example, if we write roll number, then to highlight that it's a primary key, we can put an underline below it. Right. This is the idea about. So these are the various ER diagram symbols. With itself we can make a good ER diagram. Okay. So next let's discuss this weak and strong entity sets. Okay, so simply a strong entity set is, or a strong entity is which has got a primary key, and a weak entity is something which is without a primary key. Okay, right? So you can see here the definition. The entity set that doesn't have sufficient attributes to form a primary key and relies on another for its identification is called a weak entity set. Okay. So for example, if you consider this example of the employees, okay, and there is a list of its dependents. Normally organizations, they maintain the employee data. They also keep a track of the dependents of the employees. Okay. For example, an employee wants to purchase policies for his dependents. So if we look at these two tables, the employee table and the dependent table, usually the employee table will have an employee ID, a name, birth date, address, and salary. And a dependent table would have the name of the dependents. So Ram is there, Sanju, Anshu, you can see here, and you can see the sex, the birth date, and the relationship, right? So we must have some association. We cannot associate this employee table with the dependent table. Okay, so we must have this employee ID inserted here in this dependent table, right? Because right now we are not able to see like who is the son or the brother of whom. Okay, so a weak entity set has got a partial key, right, which can uniquely identify a weak entity, right? So here, if we look here, this name is a partial identification key. It's not a very strong one. Okay. If we add this emp ID, to this name, then we can associate here that this employee ID is the father or brother or son or whatever relationship is there. Then we can associate. So we'll have that primary key here, and if an emp ID is inserted in this dependent table, it would be a foreign key here. Like we'll be working on these examples in our lab session, right? Okay. So you can see further how a partial key is represented. You can all read all this. Okay. So a weak entity can be made a strong entity by adding a discriminator sort of thing. Let's see if there. Yeah. The primary key of a weak entity set is created by a combination of the discriminator of weak entity set and the primary key of the strong entity set. Okay. So this is the discriminator. This is the discriminator. If you add this primary key to this table, okay, right? If I add this column emp ID here in this table, dependent table, then the combination of emp ID and name would become now the primary key here, and the single emp ID here would be the foreign key, because all the values of emp ID here in this dependent table would be picking up its value from the primary key here, right? So this is how we can distinguish between a weak and a strong entity set. So you can just have a reading here, because practically when we work, we'll see this strong and weak entity set in everything that we design, every table that we design, multiple tables when we are designing, then this would be coming into picture, right? Like we would require a primary key of a strong entity and a discriminator of a weak entity to create the table and make it a relevant one, right? So this is regarding the strong and weak entity set, right? So that's all for today's session. In my next session with you, I'll discuss subqueries with you, and I also discuss a very important concept of normalization. So till then, keep watching my videos. Thank you very much.